This is OwlUp, where learning happens in minutes, not hours. For a deeper journey, explore all our courses at owlup.co. Now, let's dive in. Welcome back to Chapter 2 of our series, Building Your First Autonomous Agent. In this episode titled Core Concepts and Components, we're going to break down the essential architecture that makes an autonomous agent tick. So, whether you're a curious beginner or looking to refine your understanding, you're in the right place. Let's dive in. A car drives itself through city traffic. A rover inches across Mars. And a trading bot moves millions in under a heartbeat. Yet all three live by one simple habit: sense, think, act, repeat. In this episode, we'll pull that loop apart and show why it's the core of every autonomous system. Waymo crunches a gigabyte of camera data every second. Perseverance leans on custom hardware just to keep up with Martian rocks. Racing drones twitch their motors 1,000 times per second to stay in the air. Under the hood, none of this is magic. It's an organized set of parts, each with a clear job and strict timing budget. In this episode, we'll zoom in on those parts. Sensors that don't just see, but choose what to ignore. Perception stacks that turn chaos into clean geometry. Decision layers that juggle goals and constraints. And actuators that must obey real-world physics. We'll connect these components to real design trade-offs. Speed versus accuracy, power versus capability, and onboard versus offloaded compute. By the end, you'll be ready to sketch the first architecture of your own autonomous system instead of just dreaming about one. Real systems don't run that loop in a vacuum. They're chained to constraints: timing deadlines, bandwidth limits, noisy data, and unforgiving physics. A drone can't pause gravity while it finishes a calculation. Your design has to decide what gets computed every millisecond, what can wait, and what happens when information is missing or wrong. This is where supporting components appear: buffers to smooth bursts of data, health monitors to detect failures, and logs to reconstruct what went wrong. Together, they turn a fragile prototype into something you'd trust outside the lab. Most beginners sketch autonomous systems as a neat three-box diagram. Real systems look more like a layered stadium. The star players are on the field, but a whole support staff keeps them alive, informed, and on schedule. Start with the timing spine, the clock. Self-driving cars and rovers rely on tightly synchronized timestamps so that LiDAR, cameras, GPS, and inertial data describe the same instant. Missed sync means a pedestrian might be fused with last frame's curb. That's why you see hardware time sources, shared clocks, and strict scheduling policies sitting underneath the visible logic. Wrapped around that is data handling. Raw streams are too big and too bursty to feed directly into high-level logic, so systems introduce queues, ring buffers, and priority channels. High-frequency signals, IMUs, wheel encoders, motor currents, often bypass heavy processing and go straight into fast control loops, while richer but slower signals get batched and compressed. The car that digests a gigabyte a second survives by aggressively deciding what can be dropped, downsampled, or summarized. Health and safety subsystems quietly police everything. Watchdogs reset tasks that hang. Heartbeats flow between modules to prove they're alive. Redundant sensors cross-check each other. If one wheel reports spinning while GPS says you're stationary, a consistency checker raises a flag. In critical domains, an independent safety brain can override or gracefully stop the main logic when invariants are violated. Then there's memory of the past and hints from the future. Local maps, learned models, and recent trajectories sit in specialized stores, each with rules about freshness and size. A drone or robot doesn't just react to the last frame. It reasons over short histories, and when it can, sprinkles in cloud-delivered knowledge like fresh maps or updated policies, always with fallbacks for when the link dies. APIs are the system's hands and mouth in the broader ecosystem. A trading agent actuator might be a carefully rate-limited order gateway. A warehouse robot may expose services for humans to pause it, inject jobs, or pull diagnostics without touching the inner loops. Your challenge this week: sketch an architecture for a tiny agent, a bot that watches a folder and auto-sorts files, or a script that rebalances a toy portfolio. Identify fast loops, slower deliberation, data buffers, health checks, and the exact actuators it controls. Don't code anything yet. Just map the moving parts and how they talk. A good way to stress test your mental architecture is to move away from robots entirely. Think about an email assistant that auto-triages your inbox. New messages flow in constantly. Your core loop decides what's urgent, what's a newsletter, and what can wait. Supporting components suddenly matter. A small cache of recent senders to spot patterns, a quota manager so it doesn't hammer the mail server, and a fallback rule set when your fancy classifier crashes. In high-frequency trading, teams obsess over nanoseconds in one path and happily accept milliseconds in others. Your hobby system can copy that mindset. Treat notification pops, log writes, and API calls as distinct channels with different urgency levels, not one big blob of work. As your sketch grows, notice where trust lives. Which part must never lie? Which parts can be approximate, even wrong, as long as safety rails catch them? That distinction, more than any algorithm, is what makes your first autonomous project feel robust instead of fragile. Your first small agent sketch is really a prototype for future habits. As agents spread from cars and rovers into documents, code, and finances, they'll quietly run in the background of daily life. Think of it like adding extra teammates who never sleep. Helpful, but only if you set boundaries, audit trails, and clear off switches from day one. The experiments you run now teach you where to demand transparency, consent, and human override later. As you refine that first architecture sketch, treat each box and arrow like a clause in a contract. Who promises what, how fast, and with which escape hatches when reality misbehaves. Later, when your agents touch money, safety, or reputation, those tiny contracts become your best defense, like guardrails on a mountain road you didn't know was icy. Try this experiment. Pick one real project you're working on and run it through the episode's 3 core components. 1. Clarify the exact outcome in one sentence. 2. List every constraint you're operating under: time, tools, people, budget. And 3. Map the 3 to 5 key system components that actually drive the result. For example, input source, processing step, feedback loop, output. For the next 24 hours, make decisions on that project only by asking, does this change my outcome, constraints, or core components? And ignore anything that doesn't. At the end of the day, notice what got dropped, what moved faster, and whether your next steps feel clearer or fuzzier. And adjust your 3 components accordingly. This was OwlUp, your daily step forward. To keep learning with structured courses and more insights, go to owlup.co. Until tomorrow.